tell the story to you. But I haven't told it in a few years, and I learned this afternoon that I was going to be telling the story, so I will be using notes more than I will. Just a little background is that the story of the creation of the universe is told at the beginning of every school year, from 1st through 5th grade. And it's told largely the same way, from classroom to classroom and from year to year. It gets a little bit more information on the older grades. And some of you who have younger children might be like, wow, that's really heady stuff for a first grader. But know that it's something that comes back each year. And each year it builds, and they really do start to understand more and more of it as the years progress. The philosophy behind the great lessons is to spark the imagination and to get kids excited about learning and really literally giving them the universe, like all the things that they can study and investigate. It's one of 5 stories. There's the creation of the universe, the story of life, the story of the early humans, the story of numbers and writing. And so this is usually the first story that's told. And then in the upcoming weeks, they tell other stories as well. And usually when a teacher does this, then they'll do some follow-up lessons afterward that will, maybe have the kids doing some of the ruler experiments that don't require, flame heat. They can do some of them in their classrooms. There usually are stories in other books, and some teachers do research afterwards. But without any more rambling, I think we'll start. So, Mary, go get the lights. How many of you have ever wondered about how the universe was created or where our world came from? Well, there are different beliefs and stories about this unknown beginning. But the one I'm about to share with you is one that scientists believe, and it took place 5 billion years ago. Long, long ago, before any of us in this classroom were born, before any of our grandparents were born, before their grandparents were born, before there were humans, before there were trees, before there were lakes, before there was this earth, there was nothing. There was a void, just empty space and dark. And it was very cold. And it was very, very quiet. And when we think of dark, we think how dark it is under the covers when we're in the middle of the night. But it was dark, and it was dark when we close our eyes tight. But it was much darker than that. And when we think of cold, we think of our freezers. We think of icy winter days when maybe we don't have our mittens on. But it was much colder than that. And we would think of quiet. We might think about our house when we wake up in the middle of the night. But in this space, there was not even any noise. It was total silence. Now in that dark, cold space, there were tiny particles that scattered around, and they were too tiny to see or to feel. There were tiny dust floating and wandering through the nothingness. And for a long time, these particles just aimlessly drifted through the dark, cold, silent space. But eventually, instead of just wandering this way and that, they started to come together. They began to form a kind of cloud of particles, and they began to interact, creating energy, and more of this energy was created until finally all of the energy was released in a great big explosion of light and heat.
What happened?
Everything that exists, all the matter in the universe, was part of this great big bang of explosion. After this explosion, the tiny particles were fused together in a swirling, fiery cloud. This fiery cloud of light and heat moved through the dark and silent spaces. It moved lots and lots of pieces that broken off and flew into the empty space. These chunks of matter became the millions and millions of stars in our universe. And you know of one star that became very important to us? That's right, our sun. And some of those chunks of matter became the planets that we know today. Because of those particles, some of those particles were attracted, and some of those particles repelled. And I'm going to show you a little experiment that sort of illustrates how some particles, we're going to use little pieces of red paper to represent the particles, how some of them are attracted to each other, and some are repelled. And as they float around, some of them come together, just like our planets came together, just like the stars came together, and others drifted off. Now, the Earth may seem very big, but it's small compared to our sun. The sun, in fact, you can fit 1 million Earths inside the sun. If this were the sun, this would be our Earth. Just to get an idea of how small our Earth is in comparison to our great sun. And you might think, well, that sun is so big. But even though it is so much bigger than our Earth, the sun is just a middle-sized star. Scientists have calculated there are so many stars that if each of them were a grain of sand, all the stars together would cover up all of Minnesota to the height of 130 yardsticks. With all of that sand, our sun is just one small grain. And the Earth is 1 millionth as small as that. How huge our universe is and what a small part of it we are. Now, let me tell you something truly amazing about all the matter in the universe. Every star, every planet, every single piece of matter that exists in the universe, no matter how small or how big, they follow the same rules. There are certain rules or laws of nature that every piece of matter obeys. The matter that makes up this table and chairs in this room follow these laws. The matter that makes up our bodies follows these laws. The matter that makes up the moon follows these laws. Even the matter that makes up the stars that are 1 million miles away follow these laws. Well, what are these laws? One is the law of attraction and repulsion. That some particles are attracted to each other and others repel. The particles that were attracted to each other got together to form different substances. The atoms in solids like each other so much that they can't be separated. But atoms like helium prefer to be alone. The next law is a law that says lighter things go up and heavier things go down. Gravity pulls them towards the center of the Earth. The lighter elements are on the crust of our Earth. This is like the Earth has been cut open. And the heavier elements, gravity pulls the heavier ones to the center. And the lighter ones make up our crust. And the lightest of all is called our atmosphere. I'm going to show you another experiment just to show you how lighter things always go right to the top and the heavier things fall to the bottom. I have some molasses, some canola oil, and some water. Which one do you think is the heaviest? The molasses, the canola oil, or the water? So, again, following our laws of nature. Another law is that everything we can see, touch, or smell is either a solid, a liquid, or a gas.
So this is why we usually use 2 teachers to teach this lesson, because it's usually one person does part. Ice is an example of a solid. Other examples of solids are rocks, sticks, this table, your arm. Solids are particles that are pulled tightly together and are compact, and they have a shape of their own. If I break a solid and put it back together, it still holds its shape, even though it's been broken. However, water is an example of a liquid, and it takes on the shape of whatever it's in. The particles hold together, but not as tightly as when they're solid. If I pour this water into a different shaped container, it takes on the shape of that different shaped container. If I add watch what happens if I take and put a drop of food coloring in. The drop doesn't maintain the shape of the drop. Instead, they don't take the shape. Instead, the light particles of the food coloring roll around and freely, and they spread out slowly through the water, taking on the shape of the container. They can't hold their old shape. Air is an example of a gas. Another example is helium inside of a balloon. In this gaseous state, the particles do not hold together at all. They move freely in all directions. If I spray this scent, it will pass this. It's non-chemical. When I spray the scent, the free movement of the air will carry the scent across the room. Please raise your hand when you can smell it. Solid, liquids, and gas. All the matter of the universe is in one of these 3 states. Another law of nature says that when something is a solid, a liquid, or a gas, depends on how cold it is at any given moment. Water is usually a liquid. But what happens if it gets very cold? Yes, it turns into ice. And if ice starts to warm up again, it turns back into a liquid. And what if you heat up the water? And it turns into steam. Again, it stays in one of the 3 states of matter, but it just depends on the temperature. So I've got another experiment to show you. Here's a piece of wax and a piece of solder and a nail. Which do you predict will melt the quickest? Wax. But I want you to watch up here, and these have been so handy to have in the classroom when you do these experiments. It was always so hard because everyone wanted to see. Oh, I should have them all on the same camera. It's not very active experiment. So you can see the wax is turning to liquid rather quickly. But as you notice, the solder is also beginning to melt. But the steel, what do you notice about the steel? It has maintained its shape. It would melt if we heated it up for a much longer time. but it would take us it would have to have much hotter.
Worried about the fire alarms.
Yeah, that's right. Thank you.
Yeah.
I know, so would I. Okay, so now, let's go back to when the earth was first formed, billions of years ago. It was not at all like it is today. It was very hot, and it was much too hot for anything to live on it. There were no oceans, there were no lands, it was red hot, spinning ball of matter. But even then, it obeyed the laws of nature. Over a long period of time, following these laws, the earth slowly changed to become the planet we know it today. Following the law of gravity, the heavier things went to the center, moved downward and inward toward the center of the earth, and the lighter particles moved upward and outward towards the surface. The particles at the top began to cool because they were exposed to the coldness of outer space. So they began to turn into a solid and formed a crust over the surface of the earth. But deep inside the earth, it was still very, very hot. And as this heat built up, it put pressure on the crust. And in some places, the pressure, we're going to get that up over here, the pressure became so strong that the Earth's crust could not hold the heat in anymore, and it exploded in volcanoes all over the surface of the Earth. Yes, it is. And we didn't put as many chemicals in as we do for the children, but there we go.
Yes.
Oh, that's so cool. Lava, which is liquid rock, and hot gases poured over the surface of the earth. Because the gases were so light, they moved up and formed a cloud around the earth. Over time, these clouds cooled and turned to water and fell back on the earth again as rain. But the earth was still so hot that the water instantly evaporated and rose back into the sky, where it became a cloud again. There was this poisonous cloud covering the surface of the earth, and it blocked out the sun. Now, over time, this happened. The cool rain came down and turned to steam and went back up into a cloud of rain. And I'm not going to actually do this, but what you typically would do is you would have a hot plate here and you would take that, you would drop water and then it would raise up and drop again. Eventually, the earth cooled enough that the water rained down and it stayed on the surface of the earth instead of instantly returning to steam. And so as the cold particles came down, it hit that hot, fiery ball that still was our Earth, and it would rise up again out into interstellar space, and those cool particles would get cool, and they would fall again as rain. And this dance went on for a very, very long time. And eventually, the Earth cooled enough that when it rained down, it stayed on the surface of the Earth. The Earth, instead of returning, and this is how the ocean and rivers formed. The highlands became our mountains and land, and the lowlands became our oceans and rivers. At this point, our earth had land and water. There was still no life. There were no animals. There were no plants. But it was a beautiful place and was now ready for life on earth.